Hello everyone, my name is Christopher Grötsch. I'm a solutions engineer with Keysight, and today I want to talk about how you can create solder balls for multi-technology assemblies in ADS and RFPro. So let's assume you have a setup that looks like this. You have a PCB where you want to mount different components on top. This could be another PCB, this could be ICs, and they are connected by solder balls. For example, because you want to simulate a trace running from, in this case, mount 1 through the solder ball onto the main PCB and up through the solder balls again to mount 2. As you can see for this example, I'm using very simple dummy boards. So the main PCB is just two traces connecting the two locations of the mounted components together, and the mounted components are also just simply two traces traversing through the layer stack down to the solder ball, and the same for mount 2. In this video, I will show you two different ways to set up solder balls. The first one would be as an approximation using vias, and the second one would be using a real solder ball shape. And for the solder ball shape, there are also two different ways to include them in the layout. So let's dive right into ADS, where you can see that I've already opened the workspace that contains the main board. So let's have a look at the layout. If I open that, you can see this is what I've just explained. Two traces connecting the two locations with the landing pads for the mounted components. Of course, in the next step, we have to add the mounted components, mount 1 and mount 2, to the workspace. And I already prepared that other workspace. So I created another workspace where those components live, and I add that to my mainboard workspace. So let's go to Manage Libraries, add library definition file, and I have this workspace called mount component that contains these mounted components. And let's add those to the workspace. And now you can see we have the two mount components in our workspace. And if I open the layout, you can see that I have added a circuit component in each of those layouts, which will be our dummies that I want to connect to each other. So the idea is to simulate a transmission from the circuit component from mount 1 to the circuit component in mount 2. Now, to mount these components, we have to set up the library as a smart mount library. And we can do that by doing a right click, going to technology, nested technology. And then you can see I already did that here. So we go to nested technology to the tab. You can see the smart mount type. In this case, it's bottom mount, and I activated map layer and align, and automatically use smart mount proxy piece for all designs in the library. For more details, we have videos just focusing on how to set up these smart mount components, and I won't go into detail in this video. Now we cannot mount the components mount 1 and mount 2 directly on the main board, because in that case, the backside metallization of mount 1 and mount 2 will sit directly on the top metallization of the PCB. And of course, we want to have these solder balls in between. Now I will start, as I said, with a via approximation of the solder ball, and we can add that directly into the substrate of the main PCB. So what we have to do is we open the main substrate, and the solder ball is supposed to sit directly on the top metal layer of our PCB, and that's the cont layer. So what we want to do is we insert a substrate layer above, and this substrate layer, we set it to air, and we select a thickness that corresponds to the thickness of the solder ball. Now in this case, I will choose a very high thickness in order to have a better visibility of the solder balls in the overall layout later. So let's say we have 200 here. As I said, the solder ball is going to be represented by a via. So what we want to do is we want to map a conductor via to the layer stack. And this will be used to draw the solder balls in the layout later, this via layer. And we will create a new layer for that via layer. So let's call it solder ball via. You can, of course, use perfect conductor, but you could also, for example, use typical solder. And if typical solder does not show up in your material list, you can go to the material definitions, add from database, and here it is, and you can add it to your material list. Now, the smart mount components can only be mounted on top of a conductor layer and not on top of a via layer. So that means we have to create another layer in the top interface here that we can use as a target for the smart mount. Now what we want to do is we say map conductor layer, and also here we add a new layer. Let's call it dummy mounting layer. And this will only be used as a target for the smart mount component. That's it, and we finally save the substrate. Now to add the solder balls to the layout, we open the main board and we simply use the circular drawing tool to draw vias into the layout. So we select the solder ball via layer, and now we can, let me center that. Now we can draw a via on the landing pad where the solder ball is supposed to sit. And we can repeat that step by step for all these landing pads of the for the mounted component. We can also make use of our copy and paste step and repeat option here. You just have to know the spacing in X and Y direction, numbers of rows and columns. And voila, we have created our solder ball array. And we can do the same thing with the ball grid array for the second component. We will just draw the first circle here. And with a space bar, I can iterate through shapes at the same location. So in this case, I have the shape with the cont layer, so that's landing pad, but I want to have the solder ball via. So by pressing space, I will go to the solder ball via drawing. And then again, I can go to copy paste, step and repeat, and I get my full array here. And that's it. So let's have a look how this looks in RFPro. So we should already see the solder balls. And as you can see here in white, they show up. We have our solder balls as via approximation. Now we'll just have to add our mount 1 and mount 2 components. So let's go to the component library by pressing I on the keyboard and selecting the mount component library. So we can use mount 1 and mount 2, simply aligning those with the ball grid array. And now with the last check, we can see the mounting layer. And as you can see, automatically the dummy mounting layer is chosen. So we really mount it on top of the solder ball via. And the same is true for the mounting layer of the mount 2 component. Now let's have a look in RFPro. Let's save this layout. Let me switch to wireframe view. And now we can clearly see that we have our two traces starting from the circuit component on mount 1, propagating through the solder balls or the via approximation of the solder balls onto the main board, going over to mount 2 through the vias there, and then connecting to the circuit component on mount 2. If we want to simulate that structure, we can use a full EM analysis. And all we have to do is now create ports for this analysis. And we can easily use the pins of the circuit components to create those ports. So we select those pins of the circuit component 1 and circuit component 2. We will create reference pins for those input pins, let's say on the next ground net. And now we can simply drag and drop those pins into our EM analysis section. And as you can see, automatically it will find the nearest ground pin. This is the one that we just created, and add them to the analysis. So we have ports ready for simulation. Afterwards, we only have to set the frequency range of the simulation, and we can run it. As I said in the beginning, I want to show you two ways of setting up solderballs in ADS and RFPro. The first one that we just covered was the via approximation, and the second one is a way where we use real solderball shapes. In order to do so, we will start with a fresh workspace where we just have our main board and the mounted components, and we will use the substrate that we defined before, where we added the air layer and dummy mounting layer. We are not using the solderball via layer anymore, so this is not necessary anymore. So first of all, we have to create the solderball shape, and we have to get it into our layout. And the first way to do this is using EMPro. EMPro is our 3D EM modeling environment, and you can download the newest version from our homepage. And if you have access to RFPro and the solvers there, you can also use EMPro. Let's start EMPro. And all we want to use in EMPro is this solderball creation menu here. So you can see we just fill in our dimensions of the solderball, and especially the height. I think we use 200 milli-inch here in that example. We press done and we have our solderball shape. Now the next step would be to add a material to it, and we can do that in the material definitions. We select a default material from the library, and we can use again the typical solder material in the bottom, and we drag and drop that onto the solder ball, and now we're done. We have our solder ball shape with a assigned material, and we can then now use that in ADS. If you like, when creating the solder ball, you can also, instead of putting in a fixed parameter, you can put in a variable to change that later also in ADS. Now we have to save the project, and we call it solder ball, save, and let's go back to ADS. And now what we can do in ADS, we simply go to manage libraries, and we'll open we will add the solder ball file. It's saved in a library. We'll add it to our workspace here. So you can see we have the solder ball library here that was created when we saved the solder ball, and we select the folder, we press OK, close, and now we have a solder ball shape in ADS, where we can, for example, also directly go to EMPro, open that and edit it, and we have the layout footprints that we can use to add it to our layout. And let's do that. So we open our main board, we look for the solder ball in our library, and we can just simply add it to our layout here. Now to populate the array, we can again use the copy, paste, step and repeat. We just have to use the proper spacing between the solder balls. In this case, it's 12, and we put them here. Let's save this, and let's have a first look in RFPro how this looks like. So now you can see it's loading the 3D components, which will be the solder balls. And as you can see here, they are. To replicate the same steps that we had with the via approximations in the last part of the tutorial, let's add the mounted components on top. So we take mount 1 and mount 2. We properly align them with our ball grid array. We save the design. We go to RFPro. And now we should have a ready to simulate assembly here. So you can see we have our solder balls connecting our mounted components to our main board. And it's getting clearer if we use this little slider on top. Then you can stretch the entire design, and you can see there's really a connection here. Let's go back to 1. Another way to check for a connection would be this little connectivity symbol here on the right side. If we press that and press somewhere on our trace here, you can see everything that's highlighted right now is connected. And so we have a good connection from mount component 1 to 2. And if you select the second trace, you can see that it's also fully connected here. Another thing to notice if I just select the nets, so let me select the trace 1 and trace 2 on the main board, you will see it will not propagate through the solder ball. That's because the solder ball is now a 3D component, and 3D components cannot be part of a net. To set up the simulation, we will again do the same steps as described before. We will use the pins of the circuit components to create the ports. First, we need some reference pins. We will create them using virtual pins. We drag and drop the pins to the port sections, and then we have our input and output ports. Now it's complaining that momentum simulations do not support 3D content. That's because if we go to the options, we will have to select our FEM simulator to simulate a such structure like that. We have to do that anyway because we have a smart mount multi-technology setup, and that always requires FEM simulation. Now we can run the simulation with a real solder ball shape. For the second way to simulate real solder ball shapes in RFPro, we'll start again with a fresh workspace where we only have the main board and our mounted components, and we will use the same adjusted substrate that we've used before with the additional air layer and the dummy mounting layer. Now in this case, we want to go directly to the mainboard layout. We'll go straight to RFPro, because what we want to do is we want to add the solder balls directly in RFPro. And as you can see, we have this little solder ball icon on top of the layout, and it will open the same solder ball creation menu that we had in EMPro, and now we can fill in the parameters of the solder ball. So we take in the 200 milli-inch, and as you can see, it already appears in our layout. Now we have to move the solder ball to the proper location, so to one of these solder pads, and we can do that by going to specify orientation. We can use these little arrows to move it in the layout until we hit the right spot, or we can simply go to advanced mode, use this little cursor icon here, and then select a location in the layout, and it will just align with that location. And we press done, and we have our solder ball shape in our layout. To populate the ball grid array, we can use this create pattern option here, which is very similar to the step and repeat, copy, step and repeat in the layout. In this case, we have a rectangular array here. We fill in the spacing between those pads, the rows and columns. We press done, and then we have populated our ball grid array here. Last but not least, we have to also assign a material to our solder ball, and we can go to a material definitions. We already have material in our database because we defined it in our substrate. We defined our dummy mounting layer as typical solder and also the sphere layer. So it shows up in the material definition, and now we drag and drop that onto our solder balls, and now we have assigned a material to all of the solder balls of this array. And we can repeat this process for the second array. We go to specify orientation, advanced, We use this arrow, align it with this pad on top here, press done, and then create pattern, rectangular pattern. We set in the spacing and number of instances, that's all correct. And then we assign a material to that array. And now we have our solderball arrays. We can save this now, close RFPro again. And in the layout, what we want to do is, of course, we still need our mount 1 and mount 2 in the layout. So let's add them. I do it after creating the solder balls in RFPro because then these mounted components are not in the way. It's easier for me to create the solder balls. Let's save that. Let's start RFPro again. And now we have a ready assembly. So you can see my mounted components sit on my solder balls, and we can simulate a trace running from the circuit component of mount 1 to circuit component of mount 2. So let's check for the connectivity again. Yes, so let's go to wireframe. And as you can see, we'll see the connection propagates through the solder balls, and the same for the trace too. So it's ready to simulate. And in order to do so, we follow the same steps that I've described before. We reuse the pins of the circuit components. We create a reference pin on the next ground net, and then we drag and drop them into our analysis, and automatically it will find the reference, add them to the plus pin, and we can simulate the setup. Change the frequency plan, and of course we have to set the simulator to FEM, and then we can run the simulation. So in this video, we covered two different ways to set up solder balls in ADS and RFPro, first with a via approximation, and the second way was with solder ball shapes, either coming from EMPro and imported into the layout and assembled there, or assembled directly in RFPro. I hope you find this video useful and that you can use one of these approaches with your own designs. Thanks for watching this video, and if you have any feedback, feel free to leave a comment.